Good day, beloved machine learning full stack interns. Ladies and gentlemen, it's a beautiful good day, ladies and gentlemen. It's a beautiful Saturday afternoon here in Lagos, Nigeria, from where I am joining this call, and we are glad to have you all here with us. My name is Chigozie Mbonu, a data scientist at Hamoye AI Lab, and I would be your host for today. I must say you are all in for a real treat today, as these beloved interns here have pulled up their socks in the last 2 weeks to develop a proposal for a project, which they will be completing in the Hamoye Summer Internship, May 2021. The projects are aimed at solving real-life problems, and they will be developing end-to-end user explorable solutions that will fit the demand of man by applying techniques, concepts, and algorithms from machine learning. Today, our interns are going to make a project presentation, which is a step towards a blissful machine learning career and building the future of work. With us here today is the advisory team made up of incredible and selfless professionals who are ready to listen to the presentations, point out where needs more work, and also provide recommendations that will ultimately lead to the success of this project. Dear interns, ladies and gentlemen, allow me the honor to introduce to you the members of the advisory team here present. Firstly, we have here with us Mr. Gaurav Jain, who is from India. He is a data scientist with Hamoye AI Lab. And on the advisory team also, we have Ms. Muhammad Saliyat, who is a lead data scientist at Hamoye AI Lab that have successfully and continue to build solutions to problems in machine learning, artificial intelligence, and deep learning. It's great to have you join us, guys. Before we proceed, here are a few housekeeping rules I would like to point out. Each group is expected to make her presentation in not more than 10 minutes. At the end of every group's presentation, the members of the advisory team can ask the presenters any question. The members of the advisory team will give their recommendations at the end of all 3 presentations. If you have questions or need to make comments, please use the chat box at the bottom of the screen and it will be attended to. If you must speak, please feel free to raise your hands and you'll be unmuted. To the presenters, please ensure that your display name is the name that you have used to join in so we can identify you easily and grant you screen sharing permission. And now, without further ado, allow me to introduce to you the presenters. Firstly, we'll be having 3 groups, like I said, and I'll be introducing them intermittently. After a group speaks, the judges will be giving us a few recommendations before I call on the next group. So give me the honor to call on John Nolly and Big Ogunyemi, who will be speaking on behalf of Stack 01. You have the stage, guys.
Hello, everyone. Can you hear me?
Yes, we can. We can hear you.
Okay, so can I share my screen now?
Yes, you can.
Okay.
John.
Yes, can you hear me?
Okay. Yeah, we can.
Yes, can everyone see my screen?
Yes, we can.
Please proceed.
Yes, we can see your screen.
Okay, it's an honor to be here once again at Hamoye. Last year was a wonderful year, and I was also amongst the interns that interned last year. So without further ado, I would like to just take us through the proposal that we have developed, myself and my team, and we would like to share with you guys and get feedback. So the title of our presentation is Amazon stock price prediction using deep learning. Our group is Stack 01 group. Okay, so here here is our contents, the things that we will be discussing in this presentation. We have the introduction, the problem statements, aim and objectives, literature review, and the research methodology. So we all know that investing is something that has gained a lot of traction and something everyone wants to go into, because the wealthy and successful people are people that invest a lot, and stock is one of the investment platform that people engage in. And stock is just a fractional ownership of a company, and the stock market is basically a place where these stocks are either bought or sold, basically where stocks are traded. And the behavior of the stock market price um, is just the movement of the stock either upward or downward. So, and we all know that we should not trade stocks based on just optimism, but based on arithmetics and based on a lot of decisions and calculations. So I'll go to the problem statement. Here we see that the behavior of stock markets is gaining a lot of interest from both investors and also scholars because of the potentials in the stock market and how um, it helps and helping traders to get better understanding and make good future decisions. So the fact that the stock market is fundamentally non-linear, dynamic, and random makes prediction of the stock market really difficult, makes it a difficult task. So this is the reason for this study, to ensure that investors or scholars would have a good understanding of what to do. Of course, the stock market involves a lot of parameters, but this study aims to propose and design an efficient buy and sell recommendation system for Amazon stock by predicting the trend in the stock movement. So um, our project will basically be narrowed down to the Amazon stocks, and some of the objectives that we have here to collect the stock data from Yahoo Finance, then build the end-to-end ML solution, then also deploy that solution via APIs as a web app so that the end user would have an interface to relate with and get those predictions and use that as a yardstick in the stock market in trading, either to buy or to sell. So here we have literature review, because of course a lot of research has been done, a lot of study has been done based on the stock market. So we have that, we all know the ARIMA, which is the autoregressive integrated moving average, is one of the most widely used algorithm for statistical, is a statistical method used for stock price prediction, but it is fraught with a lot of uncertainties, and because of this, the assumptions cannot be relied upon. We also have the classification and regression tree, which is also a very good tool. And in a research by Adebiyi, we saw that the cat produced a high predictive power like that of the deep learning models, but that research had some incomplete data, so we cannot basically depend on that. But the emergence of artificial neural networks in the past decade has seen a wide use in predicting financial time series, and it has a very high accuracy. This is the reason from our research we have chosen to use a model based on artificial neural network, which we'll discuss later in the research methodology. So to our research methodology, we have the machine learning workflow. First, the problem definition, which we've defined already, which is trying to predict, um, knowing fully well that people want to trade their stocks and they want to trade with the lowest form of risks and have more returns for their money. So that is the major problem. And the next stage of our workflow is the data ingestion, where we download the data set from Yahoo Finance. Then we also prepare the data sets, checking whether it's stationary, non-stationary, and doing justice to that. Also, we move to the data segregation stage, where we split the data sets to training, testing, and the validation to ensure that the model is well trained and appropriately trained. Then we also evaluate the model, um, changing some hyperparameters to ensure that the best quality of that model is obtained. Then we deploy that model using some APIs like Streamlit, and can deploy that on and host on Heroku, which is a popular website for hosting machine learning models. Then we also perform monitoring on that model to ensure that the model we've trained is constantly giving exact results, and we can see a feedback to the data ingestion, meaning that at some point, if the algorithm is no longer performing as it should, which obviously happens over time, then it goes back to the ingestion stage, where we um, perform the whole process again. Then the proposed machine learning algorithm we'll be using is the long short-term memory, which is the gold standard for the recurrent neural network, which is gaining a lot of popularity these days and has proven to have high efficiency and high accuracy in predicting stock prices to be precise. And it uses gated cell to track information over multiple time steps, allowing them to understand long-term dependencies and overcome the vanishing gradient problem, which makes them very good for time series. So here is a brief of our project proposal, and thank you for listening, and I would get feedback from the judges now. Thank you.
Thank you very much, John. That was a very good presentation. Over to our judges. Zaliat, please.
Okay, so good afternoon, everyone. Thank you, John, for the presentation. I think I learned one or two from there. So I just have some few questions. So the Yahoo data you were talking about, right? I don't know if you can hear me.
Yes, I can hear you.
Okay, so it's like a time series data, if I'm correct.
Sorry?
So it's a time series data, if I'm correct.
Yes, a time series data.
Okay. So what are the factors you are looking at? Because actually we are working on a project from our end on time series too. And for you to make predictions about the future, you have to think about different factors, right? So for example, now the crypto markets, Elon Musk can just come and tweet about something and then the market keeps crashing. So what are the factors you're considering?
Okay, like I said initially, when people invest, they want to invest not based on optimism, but based on arithmetic. So where this model comes to play is the fact that when predictions are to be made, that's this not taking into account other things that can happen. For example, the president delivers a speech that affects the economy, or Elon Musk, like you said, things like that. So these model is just predicting based on not considering those situations around, just on a clean slate when things like that. So this is just like a guide to either trade or not. And while the person considers this the prediction, the person will also take into consideration, because of course we cannot factor in when some of all these things can happen. Just the way nobody knew Elon Musk would just wake up one day to say some things that really affected the whole market. So those cannot really be factored in when we consider predicting for the future. So this is more or less like a guide, instead of just basing your prediction on just being optimistic.
Okay. I don't know why you stopped sharing. I wanted to go back to,
Oh,
I think,
sorry.
the slide where you
Let
had.
me let me reshare my screen.
Okay.
Okay, let me know when you can see my screen.
Yes. So can you go back to, I think, the proposal where you had the proposed methodology?
Okay, that's this one, right?
No, the next. Yeah, this one. Okay. So for presentation's sake, I feel like this was too, it's jam-packed. You get it?
Okay.
So next time what you can do is, so that we can actually see the image or the diagram that you have here, it would have been better if you separated the diagram from the text so that we can
Okay.
see the. So for the, you said you are going to do model deployment, right?
Yes.
So what tool do you intend to use for
Okay,
the
yeah.
deployment?
Research is still ongoing, but the so far what we concluded is that we would use this Python-based framework Streamlit for deploying the model as a web app. Then we can also host that model on Heroku so that it's someone from anywhere can access that web application.
Oh, okay. So have you considered using Kubeflow?
Yes,
Or,
yes. I've considered using Kubeflow and also building pipelines, but the thing there is using Kubeflow. Obviously, we know that the Google Cloud Platform requires um, payment for the space you use and things like that. And even the free month trial is just lasting for 3 months. So we want a platform where someone can easily have access to the web application at any point in time. And our best bet is still Heroku. And of course, we'll still build the pipeline, a reusable pipeline for someone that would want to run the pipeline or the model on Kubeflow and Kubernetes.
okay, sorry for, I think I'll leave I'll give the control now to Gaurav to. So thank you very much for the presentation.
Okay,
I'm
thank
Gaurav.
you very much.
So I liked the presentation. Yeah, it was like short and precise one. So a few points like Zagat have already discussed and like a follow up on them. So the data you are scraping, is it that's from Yahoo, right?
Yes, Yahoo Finance.
Okay. So is the data coming live, or like you have only a fixed amount of data that will fetch once, or is there kind of a scraper which is like continuously fetching the data?
Sorry, I didn't get that. Can you repeat that?
Okay, so do you have a scraper which will continuously fetch the live data, or is it like you are training the model on some fixed data set and then predicting every time from that fixed data set only?
Okay, yes. We for now we would be training based on the fixed data set, but of course we can also factor in um, training continuously, because of course we can always pull the data set from Yahoo Finance to Python and run it, just like the way I said, performance monitoring will be done. So we can also factor in that. But for now, we'll be training the model based on the fixed data.
And in this, like there is, you have drawn a line from performance monitoring back to data ingestion. So is it some kind of a feedback data you are putting back into the database, or what is? Can you just more explain on it?
Okay, yes. Just like we all know that whenever a model is deployed, over time, the model lacks that accuracy and that sharpness over time. So this is where that is where the feedback comes from, because when we get, maybe for example, new data set that that model is not used to, so that data can actually be fed back to the ingestion state, where we download that data again, just like you said, the continuous, a dynamic system, so that the data is now prepared again and the model is retrained, and it ensures the model is continuously sharp and gives accurate and a good result.
Okay, so basically, it's a part where you will be having a dynamic process for from like starting to ending.
Yes.
Okay. Okay, that's fine. And also, like you said, you will be using deep learning frameworks or like neural networks, basically. So,
Yes.
do you have any like plans, or have you researched which kind of model you will be working with, or what will be the architecture of the model?
Okay. For now, we've researched that the algorithm we'll be using is the long short-term memory, and over time we would determine the layers that we'll be using, the epochs that we would use, the batch size, and things like that. Over time, when we get to the training of the model phase, we can determine all those hyperparameters. But basically, the algorithm that we've chosen based on the research and from our literature review and the research that has been done, the LSTM is an algorithm that is very much suited for time series problem like predicting the stock market price.
So, just last thing from my side. So, there is a kind of situation, if you have heard of, that is stock market bubble. So, where like the whole economy is going down and the stock market prices are just rising and rising. They are just forming a bubble which will burst anytime. So, have you researched upon it? So, like, will your this model, which will essentially be a guide to people, how it will tackle it, or like you are still going on to research it?
Sorry, can you repeat that? I did not get what you
Okay,
said.
so basically, in stock market, there is a condition of stock market bubble where like the whole economy is going down, and contrary, the stock markets are going up, which is like not a normal situation, and which is like currently in many of the countries it's happening right now also. So, have you researched upon it, or will you be going to research it? Like, how will your model will be catering that situation?
Okay, okay. Based on that, like I said, we still have a lot of research to do. So I think would factor in that and would
Okay.
research that.
Yeah, you can include that point. And overall, the presentation was fine. It was short and crisp, so like it was fine. Just yeah, you can distribute the text over like multiple pages. So like in this page only, as Elliot mentioned, it becomes some sort of clumsy. Otherwise, it's
Okay,
fine. All the best for your project. That's from my side.
okay.
Yeah,
Thank you
thank
very
you.
much. Thank you.
All right.
Thank you very much, John. That was a very lovely presentation. And thank you very much, our judges, for your input. I
Thank
would
you.
like to make known to everyone that one of our judges, a very experienced data scientist, in the person of Mr. Richard Odonto, who is the CEO of Hamoye AI Lab, is also here with us.
Hi
Welcome
guys.
on board, Mr. Richard.
Yeah, hi Shigazu. Sorry, I missed the beginning, so carry on.
Thank you very much. So I would like to call on our second group, Stack O3, represented by Oluwafemi Abiona and Rokiba Olarewaju.
Yeah, good afternoon, everyone. Can you all hear me?
Yes, carry on.
Okay, I'm trying to share my screen now. Just a second. Coming. Okay, I'm sharing my screen now. Okay, good afternoon, everyone. It's nice being here again after last year internship program, and I thank God for the training so far. And so far now, with the new summer internship, myself and my team are working on the project on global food price. And then the aim of this global food price, okay, before then, I have four of my team members here, myself, Mr. Kiba also here with me, Mr. Emeka and Mr. Abib. And our project will be talking, the table of content will be treating the introduction, the problem statement, the aim and objective. Then we'll look at literature review, scope of collecting data, machine learning workflow, and in the end, the web application, just as stated in the proposal. So a brief introduction about global food price is like what is the essence of talking about global food price. We describe it as the average price of food commodities in countries, and over the years, the rise in food price has been overwhelming. Though ideally, food price actually depend on some certain factors of production, from the planting phase, then to the food marketing and the food distribution phase. But recently or should I say, there are some factors, actually external factors, that can also affect this normal process, which include the market demand, the energy costs, government policy, exchange rates, weather events, and we have so many others. And brief history of how the whole thing started: in 2007, there was a surge in food price, and particularly in some very developing countries, it became a crisis, like a serious one, leading to economic instability, political instability. There was social unrest, and that is what has made food price a problem on its own. And that's why we want to find a solution. So over the years, there have been this alternation the in the surge in food price, and recently it was shown by the Food and Agricultural Organization that month, which is alarming, and we need to find something to do. So apart from the fact that it affects the balance of market demand and produce, we also see that it has impact on the cost of living, migration, and usually the producers are always on the benefiting part while the consumers are on the other parts. And this actually now causes the fact that food availability becomes a problem when people can't afford to get as much as they want to, and the quality of the diet is also another problem. Hunger, and in line with the United Nations Development Program, um, SDG 2, is to get rid of zero hunger. So that is one more reason we are looking into this project. So the problem statement here we have is that from our previous discussion, we see that the global food price fluctuation has caused famine and population shift. Some people have to migrate to other countries, and then famine when they can't afford much. So we want to identify some drivers of global food price and predict the changes of food price and project and see what is expected, and then will help us to understand the price of food and its effect it will have in the long run, so we can do something about it. So the aim of this research is to analyze fluctuation in global food price, the outcome, its currency fluctuation. So specifically, we are narrowing down our search to the correlation of global food price with currency fluctuation, weather patterns, and refugee movements, because there are so many factors affecting it. So we'll be narrowing down our search to those three, and then we're performing an end-to-end analysis on a food prediction engine. And the purpose is to help the government make better decision and policy adjustments. So also international bodies can also assist maybe with some food program, probably because of a particular weather, they need to look advise, plant, and then provide the necessary resources that will be needed. So how we hope to achieve this, we analyze the data sets available and observe, make inference about the changes in food price, fluctuation, and the trend they follow. Also, we attempt to compare their correlation with the factors we have mentioned, the currency fluctuation, the weather patterns, and then the refugee movement. And we also investigate food item controls. We investigate which food item actually controls the trend and the majority of the food market, because we have certain classes of food. So we pay attention to some of the food items that are actually having that heavy effect on others. And then we use our best performing model to predict the food price and deploy it into an application that can predict food. So very briefly, most of the work that has been done, which is the literature review, are majorly um, has been centered on policy making actually across the nation. Like it has majorly been on policy making, how to adjust planting and the likes. And particularly in Nigeria, and the from the micro perspective now, most of the policy in the past and the present has just been to, okay, let's alleviate food price. What should we do? Okay, Operation Feed the Nation. We have a big farm, we employ people, and so even all this being implemented without having the right knowledge might not solve the problem. And so, with regards to some of the past um, work that has been done, we checked. We saw that majorly one of the major predictive modeling technique that has been used has been artificial neural network, and we also have time series forecasting algorithm like ARIMA, which has been used recently by a researcher in the global food price domain. So we hope that in the course of our work, we'll adopt this method. And then now to the data collection. Actually, this has been a bit of challenge for us, but we are still working towards it. So based on what we said, we can't actually get a comprehensive data, just a single data that would entail all the things we hope to consider. So firstly, we are collecting data from an open source compiled by the World Food Program, distributed by the Humanitarian Exchange. So that's on cargo actually. Then data on currency fluctuation, and we have researched and we found one on the World Bank open source database. Then data on refugee movements also is extracted from refugee statistics of the United Nations High Commission for Refugees. Then the data for weather patterns will be taken from the Berkeley Earth database on cargo actually. So we hope to see how we can work with this file and match them together, probably perform independent analysis and then match them together to get our desired result. So the machine learning workflow we hope to achieve so far, then the data, we have the data volume, we have the data ingestion, so we can sort out all the necessary data we have. We have about 4 databases now that we'll be bringing data from together. And then the data wrangling process, the gathering of the data, and then we see how we can extract the major features we'll be needing. Then data cleaning section, we need to make the data tidy for use. Data processing, stationary check, then the time series modeling. So we also need, since we say we'll be focusing on, we'll also be analyzing the trend of food stuff. So we'll be checking the food, we'll be checking the season and what and what. If there's any inference we can make from there, okay, there's a planting season for this particular food stuff and this, then we'll be having our predictive modeling part as well. Then before then, the machine learning, like I said, we'll be adopting machine learning model. I'm adopting the artificial neural network machine learning model, and then we'll also be using the time series methods, and we'll be making use of logistic regression also, just as our base model to see how our data perform. Then finally, for the web app development part of the model, the end product of this global food prediction engine will be in form of coming. Okay, I can't. Okay, it will be in form of a web app that will be accessed from anywhere as long as there's internet connection. It will have a drop-down list. So majorly just a sketch. We have not really dived deep into the frame of how our web app should look like, but we'll be using Streamlight according to I'm trying to adjust this. Sorry. Okay. So the web app will be built using Streamlight service, which makes deploying model quick and easy. The model would have been worked on and perfected as a pickle file and a Python script, and is created for the usage of the model. Then using Streamlight, the interface stated above is created with Python. So this is the sketch of what we hope to achieve at the end of our work. So thank you everyone for listening.
Thank you very much, Oluwafemi Abiona, for that very wonderful presentation. And over to our advisory team for some comments and pointers.
Okay,
Richard.
so can I get started? So to the former presenter as well. So my comments are going to be generic. I'll try and comment. So whatever I'm saying now, I think it's applicable to the previous presenter and to the rest of the presenters. So I think to set the stage, we want you in this program to challenge yourself or challenge yourselves, right? So think about the quality of the products that you're going to deliver at the end of the day has to be way better than what you did the last time. The reason we put this one together for you is so that you can go further, right? So the goal here is not to figure out which machine learning model is better or build a very simplistic hub because you did all of those things the last time. So this time around, we want you to stretch it a little bit further. So just keep that in mind. So with that said, and this is why we've set this up the way that we've set it up, so that we can give you advice before you actually start the work, right? So that's why you guys are having this session with us. And I think after this as well, I'll personally look through your slides and provide some individual comments. To the extent that I can, for each of you. So now, with that said, let me just let me use this specific presentation as an example. So hopefully, the rest of you can draw some inspiration from that. When you want to solve a problem, right, the first thing you should do is, okay, what problems have been solved in the space? And what is my end goal? So you started by saying a lot of the work that's been done here was sort of policy driven, right? A lot of it was around policy. That's true. But you also need to look at, okay, so food prices is a generic global problem. What companies are looking at food prices and what are they doing, right? As an example, food is a commodity. So it's a lot of it is traded globally, maybe not food itself, but the raw materials that go into food. So think about cocoa, coffee, those things are traded, right? And so there are a lot of people building, machinery to predict the prices of these things. So that's one. You've explored the policy part of it, whereby you kind of linking that to hunger and, zero hunger migration and all of that. That's also good. So the advice is try and expand your thinking, right? Beyond, maybe what you see in a couple of research papers. Look beyond the research articles. Try and also get a sense for, okay, what big companies are out there that are solving problems in this area. What kind of problems are they solving, right? Then what can we look at that can attract attention? Because the purpose of doing this stuff is so that you can either discover a passion for yourself and maybe go ahead and create a product, or you can add to whatever work is already being done in the space, or you just prepare yourself for the workplace, right? Those are the purposes for doing this. So look beyond that. I would suggest to you, for this one, there's a company called Grow Intelligence. So make a note of that. It's actually was started by an African lady from Kenya, and it's become a big company now. This is what they do, right? They look at food prices and try to predict food prices globally, with respect to agriculture and weather and things like that. So check out the website, check out what they publish. You can get some sort of ideas from there. So that's one. The next thing I would say is when you're doing work like this, always look for if there are open source work that has been done that you can leverage off of. You don't always have to start everything from scratch, right? So look on GitHub, look at things, or look on Medium, look for whatever work has been done in this space, and there's a ton of them. Either people that have sort of built a pipeline or whatever, and try and think as a group, can we make use of such pipeline? Can we add to it, right? That's how you challenge yourself. So again, the goal of this is not to just build a model that runs end to end and then build a little app on top of it. You kind of already did that the last time, but look beyond that, right? Look at applications, look at open source projects, look at what you want to get out of it. At the end of the day, you need to wow yourself. So please, keep that in mind. So let me just say one more thing on this particular one. When you talked about refugee movement, it wasn't clear what role that was going to play. So there's obviously, features and response in a model that you are building. So if food prices are sort of what you are looking to predict, are you saying then that refugee movement can be an indicator for volatile food prices, or that food prices can be an indicator for refugee movement? So it's unclear what you want to study there, because refugee movement itself can be a project, right? And food prices can be one of the factors. Weather patterns, food prices, and so on and so forth can be a factor into refugee movement. But if you are reversing that and say, I'm going to look for refugee movement and see if that can predict food prices, that would be a bit confusing, because you would think that food prices going up would lag refugee movement, as an indicator, or food prices going down will be a lagging factor, for refugee movement. So, think about that in, the variables that you've chosen to look at. So let me pause there. I don't know if you want to answer my question, or if the other advisors can jump in.
Okay, sir. For the refugee movement part, thanks for the observation, sir. We're looking at it since one of the problem of global food price going up is large population. So when the population is too much, then the available resources become maybe not sufficient enough. So we're considering it as a factor that could still cause about insufficient food. And when there's low reserve, then there's going to be an hike in price when demand is too much than the supply. So that was what we were thinking initially, but might consider taking it out.
Yeah, so I get that angle. I think it's a difficult one, right? Because it's a bit like, again, it's a lagging indicator, and so it could confuse the process. Think about it, right? So if you want to focus on food prices, you may want to look at additional features that you can introduce. But refugee movement, it's also something that is actually worth looking at. It's just that I'm not sure that you can actually use that, to actually predict food prices. They are related, right? But just because there's correlation doesn't mean there is causation. So you want to focus on causation, not just correlation.
All right, sir. Thank you, sir.
Okay, so yeah, nice presentation, and I think you guys did great. This is actually a project I've looked at one time, but it was just a little bit of analysis. So about the data, right? I think if you can check Nigerian Bureau of Statistics, you should be able to get Nigerian food prices from there. I don't know if that would be helpful, but you can look at it.
All right, thank you, ma'am. Actually, we are considering, since it's global food price, do you think streamlining into Nigeria alone would be an option?
No, I saw you mention something about in the literature review. You said something about Nigerian price. So I was thinking
Okay.
if you
All right,
need the
thank
data,
you.
of course. Yeah. Okay, then I think the next thing is the presentation. That's the slide that you have. So I think it was too wordy, like there were too many informations. So maybe for next time you can just try and pinpoint some points. So I think while I was in school, it was advised to use just 5 points per page. So you don't have to, it doesn't seem as if you're reading from the presentation you get. You can have it somewhere else and just have the points here. So it's easier for us to capture what you're trying to say. And then I think the other thing aside that is, okay, my boss already talked about the data set. So you said you are going to create an application on top of it, on top of the model, and you're going to save the model as a file, so you can have an API on top of it and stuff. So have you considered how you are going to train your model with new data and stuff?
Okay, personally, I've not gone that far, and I'm really not in. I can call on my colleague who is actually in charge of the web app part. I'm a bit clueless about that.
Or if the person is on the call.
Okay, his name is Abib Agbaje. Let me check it.
Is Abib here?
Okay, he's
Oh,
currently around. Right.
okay, I think I'll leave a review too on that. So you guys can check out like Kubeflow and other components that come with Kubeflow that can allow you to have like continuous training. You can look at,
Okay.
yeah. So I
All
think
right.
overall
Thank you.
it was nice. So I'll leave you in the hands of Chicos.
Right.
Thank you very much, guys, for that very wonderful presentation. I'll be calling on the third and last group to grace us with the stage. Miracle Ilo and Afoleke Bayewu. Please, you can stop sharing now. Miracle Ilo and Afolake Bayewu, please. You have 10 minutes.
Hello. Hi, everyone. Can you hear me?
Yes.
Okay. Good afternoon, everyone, and good to be here. My name is Miracle, and I'm presenting Group 4. And excuse me, I and my team have come up with this synopsis of what we're going to be doing for this machine learning internship. All right, so we're talking about healthcare fraud. We're looking at anomaly detection. Here is the content we're going to be looking at. All right, a quick introduction. Fraud generally is a concern that we have in our society today. And the healthcare sector is not exempted, right? So for this purpose, it simply represents a group of individuals or a company that mistakes the type or scope of medical treatment just in a way of acquire recommendation or acquire monetary value that they are not meant to have. Why is this a concern? We know a lot of funding goes into the healthcare sector, and it's a very sensitive sector, of course. Health of the citizens of any nation is of paramount to the leadership or even external countries or external influences. So we have a lot of funding that goes into the sector, but you find out that those funding are misappropriated, and the agencies or the individuals or practitioners providing healthcare are involved in fraudulent activities just for materialistic gains. Then eventually the funds that are meant to be used for mostly the aged or probably the minors that qualifies as well aren't being used for such purpose. So that's the need for this. So our solution is very simple. It would try to get an innovative solution that will deliver on this, be able to predict if a transaction medically now it's fake or if there's a fraud element in it. All right, so the objectives are very simple. We look at the data that we're going to be working on. We try to do a lot of cleaning up, feature engineering to develop a model that shows the relationship that exists between those data sets. And of course, the ones that are relevant to predict the fraudulent health transactions. And then we go into machine learning to model the data set and come up with a solution that can test data that would be eventually be generated onwards, and then it will help the relevant stakeholders to determine if such a transaction is fraudulent, and then help them to appropriate right funding to the right place. And of course, there'll be evaluation of the model, looking at the results to ensure that our model or the algorithms we are going to be trying out are the ones that eventually come up with higher accuracy. And then in a way to operationalize or to make the solution available for anyone to access it, we try to deploy it in form of a mobile. So a lot of researches actually has gone in the line of anomaly detection generally, but it tends to be concentrating on financial transactions, like you have a money laundering and all of that. So our solution would be discussing fraud in the health sector. So we're going to be channeling the anomaly research or anomaly detection solutions to the health sector to solve a problem that we already introduced earlier. So the real world cases exist. Anomaly detection comes evident in a lot of sectors ranging from telecom to transport to social media and all the likes. So it makes our solution prominent because is beyond the health sector is much more needed in all other sectors basically. All right, so our data set is from Cargo, and we have done a little exploration of the data set. We found out that it has 27 features. Of course, by the time we will start working on the data set properly and then do all the necessary engineering and then the processes, will definitely have more than these features. And then the data set, the entry point is 100,000, which is relatively fair for us to get a good result. Although since we're working on an anomaly problem, which always have an imbalance problem, which we already envisaged is going to be one of the situations, but all the same, we would do all the needful to ensure that our model comes up with high accuracy. So the machine learning workflow is, of course, coming from the data science and previous training backgrounds. This workflow should be quite conversant with us. So we prepare the data set. After sourcing the data anyway, we prepare the data set to make it fit for our training. We do the feature engineering, and then since we are talking about anomaly detection, and then the data is not labeled, so we don't have the targets yet. So we're going to be conducting unsupervised learning method, and we're going to be exploring different unsupervised algorithms, like we have a local outlier factor, we have one class SVMs, we have isolation forests, we have self-organizing feature maps and the like. So we're going to be exploring all of them to come up with labels for our data sets. Then when we've gotten labels for data sets, we'll now use that to do supervised learning. So we'll check out other supervised learning algorithms and then use it to train the model. And then evaluation comes in, and then we'll go to deployment and monitoring. So for the deployment aspect, we could go the route of checking code flow and then eventually using serving processes like Seldon Core or KF serving or TensorFlow serving. So we could actually go that route. But we would just want to go the route that anybody that intends to use the solution could use. So we decided to go the route of using using the web application so that anybody can easily use the web address and go there and then just input the parameters, and then it comes up with the results that says that this transaction coming from this particular provider is fraudulent. So we don't need to continue using this vendor, or we don't need to pay for this service. Basically, that was why we are thinking in this line of so we're going to be using a lot of web frameworks that are popular, and then we're going to be using Django, which is also a Python-based web framework, and then using Django REST frameworks, we'll be able to develop the solution in a web app format. I think that's all from my end. Thank you very much for listening.
Thank you very much, Miracle Ilo. Over to our members of the advisory team for some pointers. Thank you.
Okay, let me go first. So, Miracle, thanks for this. Good to see you again. So I think my initial reaction about this is I understand the data set that you have and what you're trying to do with it. Well, you haven't, it's not clear to me about the context of the use case. So when you talk about fraud in the healthcare sector, in different parts of the world, obviously the government, like in the UK or in Canada, the government provides, some sort of insurance, right? So you go to the hospital as a citizen, hospital will treat you, and then the government pays. You may have a little bit of copay, but then the government pays. So there is fraud in that system. Either the user trying to defraud the system or the doctor trying to defraud the government. Okay, so that's one scenario. Now you have a scenario where there are private health insurance companies. And this is what, say, you have in the US, where there is no government insurance, but there are private companies that are providing health insurance. So you can have the same scenario. The hospital may be trying to defraud the health insurance company, or the individual is trying to make claims for, let's say for services, for services they didn't receive, from the hospital. So what part of it are you really looking at? Because that part is not clear. So when you say fraud, in which context are you defining fraud? Because that speaks to the application, right, of who is going to find this useful, who is going to want to look at it. And once you can define, precisely the context in which you are looking at fraud, like I suggested before, take a look at what companies are out there, what startups are out there doing this. What are they doing? How are they doing it? What problems are they finding interesting? And then you can refine, your project along those lines. Because it's very important that what you do as part of this project, it's something that is interesting, that it's catchy, that actually has, that would get people interested, right? It could be a Nigerian problem, as an example, if you're focusing on the country. There are private health insurance companies in Nigeria, there are private hospitals. If you want to look at fraud in that context, I know data may be a challenge, but whatever data you are using, even though you may not have data for Nigeria, you can still frame your problem in the context of Nigeria, right? So just a bit more clarity will be helpful. So let me put it back to you. So maybe just how to be more clarity, and we can go from there.
All right, thank you very much. Excuse me. Thank you very much, sir. Just like you already said it. So the angle we're looking at is very simple. We're looking at the aspect of in the healthcare providers now, the people that that provides the healthcare services that the companies or the government agencies are sponsoring now, that they are providing premium for. So in the record, because once they do any transaction, they will have a detail of what kind of transaction or what kind of services that they rendered, as well as the prescription, the description, as well as the cost for that. So we could have situations where they could either connive with the patients. When there was no issue at all, the patient just probably, has already developed relationship with the practitioner, just comes, they just make up one thing, and then it seems as if there was a medical transaction that eventually took place. But that didn't eventually happen. There was no sickness, there was no problem. And then they see it as a transaction that was done medical, and then they refer back to the agency providing the funding, and then in a way to get pay for that. And then, of course, we could also have situations where, apart from what was prescribed, probably it was just a headache. Of course, since the patient came, it was just a headache, and without the consent of the patient now, they could just prescribe it was maybe something quite more elaborate, and then which of course has more people. So such situations could be termed fraudulent, and in the long run, it simply tends to cut short the resources that are meant to be used for the health sector. So that's the angle we're looking at. So in a nutshell, we looked at cases where either the patients, in collaboration with the practitioner, is trying to defraud the provider agency, or the practitioner itself is doing the whole thing all along. So that's the aspect we're looking at.
Okay, so that's clear. So that's clear and it makes sense. So I think the other advice was take a look at what companies are out there, what startups are out there looking at these sort of problems, right? You should always do that, at least as part of these, this phase of your learning, because then that would help you conceptualize the problem in a real world sense, right? If people are already trying to solve that, how are they solving it? What are they concerned about? What does their platform, what does it do? So I think that would help you quite a bit.
All right, okay, to that definitely.
Okay, just to add a few things to what Richard said. So I think I was confused initially with the topic because you said healthcare fraud. So I wasn't really clear about so I don't know if you can reframe that to a specific use case, like you said, so that it will make more sense, because I was going to ask how different it was from the normal fraud detection that we have in other sectors. And yeah, the presentation was nice, and I actually like the fact that you are considering Seldon Core and Kubeflow too for model retraining and all that. So I was going to ask about the feasibility, because you said a lot of things about some factors, knowing whether the patient is lying. So like, what are the features you're looking at, and what kind of data are you looking at? I didn't really get that during the presentation.
All right, thank you, Zalia. So in the context of the data sets, based on the data set that we got from Cargo, and it was provided by the National Plan and Providing Enumeration System, So it has record of, just like saying, the record that those practitioners provide to this agency that entails their operations. So it involves the identifier, it involves the location, it involves the type of service, it involves the amount that was specified for that kind of cure or for that kind of service. It now involves the amount that the provider claimed that that service is worth. And so things relating the whole transaction stuff. So that's what the data set provides for us. So what we're going to be looking at is the overall type of transaction. Because if it's an outlier, if we have, based on the data sets, and we have a whole lot of transactions that has occurred from, of course, different organizations as well. So we look at the one that tends to go out of the norm. So the algorithm should be capable enough to detect that and say that, of course, this is a particular type of treatment and it's coming from this other vendor. Why is it out of the norm? So with that, we would be able to say that this particular transaction that this person is claiming is not what is meant to be, or is not supposedly true.
Yeah, I think I get it. Just one more thing. So I didn't really get, because the literature review didn't capture like methodologies that were used in the past. And maybe if you have a proposed methodology, like maybe an algorithm you're looking at, or you have not thought of that.
Yeah, okay. Yeah, for the literature review, like the research we did, of course, most of the anomaly detection that we have seen is tilted to the financial sector. Because although we also did saw some in the health sector, but they are not particular about the behavioral aspect of the practitioners now. So we look at trying to dictate other aspects of the health sector. So what we are looking at in this context is the behavioral aspects. So we're looking at the the lifestyle now, basically, with regards to the practitioners or the people providing these services. So for the algorithms, like I referenced, this is an unsupervised learning from the outset. So there's no label yet, but we intend to, first of all, using the unsupervised method, we're able to get a label for the data sets. And then using that same data set that we already provided labels for, we'll now proceed to supervised learning. So we would be trying out some algorithm. We have not done it on the data sets here, so we will be trying out on supervised learning and see the one that provides high accuracy. So we could also look at if for example, if we try out 5 unsupervised learning algorithm, we'll now say if there is a consistency in a particular point that was predicted or that was labeled by those unsupervised algorithms to be an outlier. So we'll now maintain the data set as an outlier. So it will be more like after we have done one unsupervised learning method, we'll try another one. So we look at the consistency in the result of those algorithms, and then we'll now come up with the ones that are outliers. Because as we're doing those labels that we would move over to supervised learning, it's good enough that we do a lot of confirmation so as to ensure that the labels that we're going to be tagging to a particular transaction is seemingly what is meant to be. So after that, we use the supervised learning methods or algorithms to determine the prediction aspect now. So that by the time a data set is coming out fresh, you should be able to say that this is a fraudulent transactions or not.
Okay. Thank you very much, Miracle.
You're welcome. Thank you.
All right, Chigozie, you can take it.
So I would like to add a few points. According to the problem statement, there are like a few GitHub repos you can check out, like PyLegend and Green.io. So they have a similar kind of stuff. And also, like, I just want to discuss one thing. So in the modeling part, like after understanding the problem statement, so you have used a supervised model, and at the same time you are using an unsupervised modeling, both at the same time. So don't you think that will add up to the complexity of the problem, and that could be easily done by anomaly detection algorithm, which is like uh, have a simplicity of the model? Like, you have any solid thing for that?
What you said?
Right. Yeah. So basically, you are using in the modeling part. So you have specified, like, firstly you will be using an unsupervised model, and then you will be using a supervised model on the same data set. So like the step number 2 and the step number 3. So don't you think that will like increase the complexity of the model, which it can be easily done by a single anomaly detection algorithm?
Yeah,
Like,
okay, fine. Can you hear me?
yeah, I can.
Yeah, you have a point. But look, that is, if you want to propose this case for um, a supervised learning model or a supervised learning solution, because most often in the real world, you will just have, or mostly in anomaly detection cases, you have the data coming in as an unsupervised case. So just like getting to solutions, right? So if you have your data set that is already labeled, okay, we can use this. If you have one that is not labeled, we can use this. So like proposing a solution that can handle any situation.
Okay. So, like, just a suggestion, you can try out various grouping algorithms, and you can just check outliers, and like you should focus on like decreasing the complexity of the model to the
Yeah,
extent
yeah,
it's possible. So,
yeah,
yeah,
yeah.
that's from my side. Thank you.
All
Over to you,
right.
Jivan.
Thank you very much.
Thank you very much, Miracle Ilo. That was a really good presentation. Wow, I must say it was a really good presentation from everyone. And I, for one, am really excited when young people come together to provide solutions to problems using data-driven techniques. I want to say a very big thank you to our externs for putting up this wonderful presentation. Also, I want to use this opportunity to say a very big thank you to Mr. Richard for being here with us today and mentoring our extern. It's always a privilege to have you here, speak to us and gain knowledge from you. Thank you also to Zaliat and Gurav for your wonderful pointers and recommendations. Thank you to the members of the Hamoye AI Lab team, and to everyone. Have a great weekend. Thank you very much.